Right. Power rule is one of the most important, but also the most simple rule of differentiation. Now, differentiation using power rule is it's pretty important, and that's why it's part of the calculus, understanding the rates of change of a polynomial equation. Now, polynomial equations are also found in pretty much every form. Now, let's start by doing some examples of how to use the power rule from the basics. So let's start by using a quadratic equation. So x squared plus 6x plus 2. So the simplest way to go with the power rule is to just take the terms individually. Now differentiate x squared. Now I'm just going to write it in a pretty big form. So in order to differentiate this term, you have to take the power multiplied by the coefficient and subtract the power by 1. That's it. That's how simple a power rule is. Now we take the 2, we put it in front. It's going to be 2x to the power of 1. Subtract 2 by 1 gives you 1. Now if you do the same thing to 6, which is 6x, if there's nothing, we assume that it's 1, multiplied by the coefficient in front gives us 6. Now subtract 1 by 1 gives us 0. X to the power of 0 gives us 1. So 6 times 1 is 6. Now this one is a little bit tricky, but it's alright. So we take x to the power of 0, take the 0, multiplied by 2 gives us 0. The derivative of this, 0. So the derivative of this gives us 2x plus 6 plus 0. Simplified version, 2x plus 6. Now the key thing to notice in power rule is that the power decreases by 1. Here, the power is 2. It's a quadratic function. It decreases to 1. So if you take a graph of, for example, a quadratic function, so I'm just going to quickly graph a quadratic function over here. Oops. So what do we find that the quadratic function decreases by 1. So the slope of the quadratic function is a linear function. So in order to understand the rate of change of this quadratic function, you have to derive it, which means you get a linear function. So more on this in the future videos. Quickly, thank you very much for watching. Thank you.